Hey folks, probability and set theory, that's what we're doing. So I'm pulling this out of our IM2 book, you guys. So I think we skipped it last year, at least we did at my old school. And I'm hearing that we didn't do it at this school, so I'm inserting it, okay? So how are the sets and their relationships used to calculate probabilities? Okay, so probability and set theory, okay? So here's some definitions. Hey, I'm just putting a video on, so a set is a collection of objects, usually numbers, so they don't have to be numbers, but they usually are. But they could be letters or colors or whatever. And so remember doing set notation? We wrote these funny looking brackets, okay? So each of the objects in the set are called elements, okay? And the empty set is denoted by a zero with a slash through it, or you just draw the set notation brackets with nothing in it. So something that has no elements in it, so that's the empty set. The set of all the elements under consideration is called our universal set, and we usually denote that with the capital letter U. Set C is a subset of set B, and it's written like this. C is a subset of B if every element in C is also in B. So here's a Venn diagram that shows that. You see how every point that's in C right here is also in B right there, and all of them are in the universal set, okay? The intersection of the sets, A and B, and it's written like this, A intersection B, is the set of all the elements that are in both A and B, okay? All right, so it's this little region right here. These are all the elements that are in both A and B. This would be the intersection where they overlap, where they intersect. The union of sets A and B, and it's written like this, A union B, it's like there's a U right there, is the set of all the elements that are in A or in B. So it's all of them. If I picked any point in this region, it would be an A or B. That would be the union. This would be the intersection, okay? And then we have the complement. The complement is everything else. So the complement of set A is written, hey Max, is written A with a C like an exponent, so this says A complement, and sometimes some teachers write it like this, not A, okay, so that's just a complement. Okay, so whatever A is, then not A is the rest of it. Usually it's 1 minus whatever A is, okay? So it's all the elements that are not in A. So like here's a Venn diagram. If these are all the elements in A, then these are all the complements of A, all the not A's right here, okay? All right, so use the following to answer each. So here's the information. So set A is the set of prime numbers that are less than 10. Okay, now the first prime number is 2. 1 is not considered prime, it's considered the identity number. All right, so 2 is prime, it's our only even prime number, and you remember primes, and then 3 and 5 and 7, and that's it. 9's not prime. Set B is the set of all even natural numbers less than 10, so natural just means we're not going to include 0. So 2, 4, 6, 8. Set C is the set of all natural numbers less than 10 that are multiples of 4. So like 4 and 8. So here they are. Okay, so prime numbers less than 10. 2, 3, 5, 7. Even numbers less than 10. And then here's our natural numbers that are multiples of natural numbers that are greater than, I don't know, what's this? Natural numbers less than 10. This should be less than right here. Anyway, so I don't know. I'm making lots of mistakes. So let's see. So here we go. So list A is those 2, 3, 5, 7, all the prime numbers. List B is 2, 4, 6, 8, all the even numbers, and there's all the multiples of 4 right there. Whoops, let me get rid of that. Okay, so let's go ahead and find C union B. So this means all the elements that are in C or B. Well, so since the elements in C are also in B, then it's just, this is going to be all the B's ones right there. So C union B is going to be all the 2, 4, 6, 8, okay? Because this includes all the numbers that are in here and or here, okay? So either one, okay? So C intersection B would be the other one, you guys. So if we did that, so where would they intersect? This 4 and 8, well look, 4 and 8 are here, so they have overlapping at 4 and 8, so that's just going to be the set of 4 and 8. Okay, and then A intersection B, okay, so here's A, Here's B. What do they have in common? That would be our intersection. They only have that 2 in common, so that would be our answer right there, okay? All right, so here, probability, the probability of an event, and it's written P with parentheses A, so P of A, it says the probability of A is, it's always a fraction, you guys, so it's number of favorable outcomes is the numerator over total number of outcomes. You've probably seen this in middle school before. So, and then probability is any fraction or decimal that's between 0 and 1. It could be 0, it could be 1, but something like 2/5 or 3/7, something like that that's less than 1, okay? All right, so you roll a numbered cube like you're playing Monopoly that has the numbers on it 1, 2, 3, 4, 5, 6. Event A is rolling a prime number. Event B is rolling an even number. Find each probability. Okay, so here's event A. So a prime number. So here's all the prime numbers that are less than 6. Here's event B. Here's all the even numbers that are between 1 and 6 right here. Okay. Now notice they both have the 2 right there. 1 is the identity number. It's not prime or even. Okay. So here we go. So to find the probability of A. So the probability of A, remember, the top number is favorable outcome. So there's 3 numbers that are in circle A out of 6. So the bottom number is always your total number of outcomes. So it's going to be 3/6, which reduces to 1/2. Okay. How about the probability of A union B? Okay. Well, A. Now I know the bottom number is going to be 6. It's always 6 because that's what the total is right there. Well, what are all the numbers that are in A or B? There's 5 numbers that are in A or B. So that's our answer. 5 out of 6. Okay. How about the probability of A intersection B? There's only 1 number out of 6 right there, so that's going to be 1/6 right there, okay? Good morning. I'm just putting your lesson up today. So how about the probability of the complement of A? Well, how many numbers are in A? There's 3 of them, so how many of them are not in A? There's these 3, so 3 out of 6 is going to be also 1/2 as soon as my computer stops freezing right there. All right, so probabilities with complements, you guys. So the probability of A plus its complement equals 1. So it's the rest of your 100%. That's where it comes from. So the probability of A, if we just subtract this from both sides, we get 1 minus the complement. Okay, and then the probability of the complement is going to be 1 minus the probability of A. Okay, so here we go. This is how we can answer something like this. If you roll 2 cubes at the same time, you know what, I should have done this here. So this shouldn't have been here right here. I'm going to just insert that in the next page. So you roll 2 cubes at the same time. What's the probability that you do not roll doubles? Okay, so if we roll 2 cubes at the same time, there's going to be 36 ways. I can get a 1 on the first dice, a 1 on the second dice. I can get a 1 on the first dice, a 2 on the second dice. I can get a 1, a 3, a 1, a 4, 1, a 5, a 1, and a 6. There's all the ways we can get a 1 on the first dice and a 1, 2, 3, 4, 5, 6 on the second dice. Here's all the ways we can get a 2 on the first dice and 1, 2, 3, 4, 5, 6 on the second dice. 3 and 1 through 6, a 4. So there's 36 different ways. So what's the probability that you do not roll doubles? Well, I'm going to use the complement rule, you guys. There's 36 ways. That's our bottom number because that's what probability means, favorable over total. Okay, so the complement, you guys, is just to find, it's much easier to count up how many doubles we can get. 1, 2, 3, 4, 5, 6. So there's 6 out of 36, which means the complement is going to be 1 minus 6 out of 36. So that's the way we can get not doubles right there. I don't know if you can see, I boxed these ones. There's 6 ways we can get doubles, which means there's 30 ways we can not get doubles. So 30 out of 36 reduces to 5/6. All right, if you are in my class, you're going to be getting that worksheet right there. All right, take care.